Today, we focus solely on space structures. I will take you through the main structural elements of spacecraft and launch vehicles and their primary functions. To avoid confusion, let me define here what I mean with spacecraft and launch vehicles. Spacecraft are the actual craft that go into space and carry out missions. Examples are satellites, the Space Shuttle, the International Space Station or the Soyuz capsule. They need help to get into space, but once there, they can maneuver themselves into place or even navigate and travel through space. A launch vehicle is a transporter of spacecraft, often a rocket such as the US-built Saturn V, the Falcon 9 from SpaceX, the European Ariane 5, the GSLV from India and the Russian Soyuz rocket. They often burn up after launch, although reusable launch vehicles are slowly entering the market. In the space industry, the terminology is slightly different. Instead of design requirements, the term mission requirements is used. For spacecraft structures, the following mission requirements are quite common. Structures must have a low mass with high stiffness and high strength. The vehicle must also be able to accommodate payload and equipment and must have a very high reliability. Most spacecraft are on a one-of-a-kind mission and carry expensive equipment, making failure a very costly mishap. An Ariane 5 rocket that fails costs an estimated $220 million. As spacecraft development and the associated research is often a government-funded business, there's also a drive for low cost. Even though space requires more complex and expensive structural and material solutions than in aeronautics. Manufacturability and accessibility of the structure are also important. If you look at spacecraft, which form the payload that is carried up into space by the launcher, they typically have one of two types of structures which are used to transfer loads. Strutted structures, which are often three-dimensional trusses optimized for carrying loads, as can be seen here, or cylindrical cell structures, also known as polar platforms. Polar platforms are characterized by a central load-bearing member, such as a cone or a cylinder. All loads from the launch vehicle are transferred through this cylinder, and all systems within the spacecraft, such as the measuring equipment, are attached to this cylinder, either directly at strong points or by means of struts, platforms and shear webs. An example of such a polar platform spacecraft is the Envisat satellite, which has a cylindrical shell, as you can see here. If we take a good look at a launch vehicle such as this one here, we can distinguish four main structural elements: the fairings, the stage structure, the thrust structure and the adapters. Let me discuss each element one by one, starting with the fairings. Fairings have as their main function to protect the payload during the launch from the aggressive environment around it. They must maintain their shape and are therefore often designed as shallow, stiffened structures. Stage structures are the structures that form the body of the rocket. A rocket often has multiple stages, each with their own propulsion system, so it can dispose of used stages during the launch, eliminating weight and increasing acceleration. There are two types of space structures. One, where fuel tanks are part of the primary load-carrying structure, such as the Saturn V rocket. These structures resemble a semi-monocoque structure with internal stiffeners. A second option is a separate tank, which is not part of the primary structure. There is an external skin with the internal tank separated from the skin by longerons and circular stiffeners. The infamous V2 rocket had such a structure. Thrust structures transfer the enormous thrust from the engines to the main stages of the launcher. To put a number on it, the European Ariane 5 rocket produces 15,000 kilonewtons at liftoff. This concentrated load must be distributed into the stage structure via a conical structure. Finally, the adapters. They transfer the loads from the launch vehicle to the spacecraft. Here you see the adapter for the European Hipparcos satellite. Space is definitely aviation's big brother when it comes to structures. This makes spacecraft and launch vehicle design a complex and challenging enterprise, and has not yet reached its final frontier.